In this video, we're going to be talking about this. This is an electric DC motor. This thing moves or turns when you apply voltage to its terminals. You might even say that it has a motor function. Now, I've attached wires to the ends of the connections and some tape so that you can see what's happening. And when I connect it, it spins. Pretty straightforward. Now, to reverse the direction that the motor spins, you simply reverse the connections. And it spins. Wow, so exciting. Now, in this video, and for an upcoming project, I need to make this motor spin both directions and allow a microcontroller to control it and make it very accurately controlled speed-wise and position-wise. So, I'm going to have to build a H-bridge. Let's get to building. Alright, so here are the components that we're going to be using. First off is this. This is an NJM267OD2. This is a H-bridge. Well, actually it's two H-bridges in one thing. Secondly, we're going to be using an Arduino Nano. This isn't the actual Arduino Nano, it's a Chinese clone. But for our purposes, it will suffice. Now, to use this, we've got to connect this to that. Alright, I'll build up the circuit, and then I'll be back to you. Now, I realized most of you don't know what a H-bridge does, or why we need them. So, this is our motor, okay? It has two connections, here and here, okay? Now, we'll just say that's our motor. Okay, now in order for a motor to turn, you need a voltage difference, okay? So let's say this is 5 volts and this is 0 volts, okay? Now in electronics, you say that current flows from positive here to negative here, okay? So the current would be flowing through the motor, that way, okay? Now, in order for us to change the rotation of the motor, i.e. how it spins, we need to change the direction of current. Now, as I showed earlier, what we could do is we could just say 0 volts here and 5 volts here. And then the current would flow that direction, okay? But you don't really want to be switching wires constantly, especially if you're trying to make something automated, which I might be doing later on. Now, instead, what you want to do is you want to give a microcontroller the control of it. So, you could do this, right? So you could have transistors or MOSFETs controlling the voltage. Okay, and this goes off to your microcontroller. Now, the microcontroller could switch this transistor on, which would allow 5 volts to go through here and current to flow through here to ground. Okay, then current would flow through and your motor would turn. Now, in order for current to be reversed, you would need another transistor over here. Okay, so you'd need another transistor over here. And then you'd switch this on. Okay? And then you'd have to have ground over here. And then current would flow through here. Except for the fact that there's already ground on this side. So, as current will take the path of least resistance, it will not bother going through the motor. Instead, it will just go through here and to ground. So, what you've got to do then, to make this actually work, is add transistors like this. So, you'd have to have this configuration, where the 5 volts is at the top and ground is here. Okay, now, in order to get the current to flow through the motor, let's say to get it to turn this way, we'd have to turn on this transistor, so this would be high, and then of the bottom two, so we need to get it to flow to the ground, we'd have to turn on this one. So then it would go this way, through the motor, and then to ground. Okay, and then if we wanted to get it to rotate the other way, we turn this one off and we turn these two on. So the way in which a H-bridge, well, this is essentially a H-bridge now. Now a H-bridge technically would do this. Okay, now these are NPN transistors, meaning you need a positive voltage here at the base to allow current to flow through. Okay, and these ones are PNP transistors, meaning you need a negative at the base in order to turn them on. So what we could simply do is, if we turn this on here and this one off, or this, yeah, if we turn this one on and this one off, this would turn this one on and this one on, because this is 0, this is 1 for them, and then current would flow like that. Or then we could turn this one 0 and this one 1, and then current would flow like that. So that is essentially what is inside in our little chip here. It sits like that. Now, inside this, however, now I have the circuit wired up. As you can see, I've only used half the chip, half the pins available, because this chip has 2 H-bridges in it. So, for this example, I'm only going to be using 1. As you can see, when I connect power, nothing happens. And that's because, as I showed earlier, there is no input, there's no signal to turn on the transistors. And that comes from this thing down here, the Arduino Nano. This microcontroller, when I program it, will give the signals to make the motor spin. So the next thing I've got to do is program that over to the computer. Alright, so here at the computer, to program the Arduino, we're going to be using the Arduino IDE. So I already have it opened up down here, and here is what I have written. Okay, so the first thing up here is void setup. So basically in this part of it, all you're doing is initializing things like, for instance, here, pin mode, 10 output. So this is just saying for the entirety of this program, pin 10 is going to be an output pin. So basically pin 10 will output information. So it will either send out a high voltage signal like 5 volts or low, i.e. 0. So that's all this does here. And I've done that for all 3 of them. Now down here in void loop basically means everything within this bracket and this bracket here. It's repeated forever. Okay, so the first thing I've done here is digital write 8 high. Now first thing, digital write. Digital means either 1 or 0, and write, basically we're just saying, okay, 8, you're going to be either 1 or 0, and we've specified that it's going to be high or 1. So it's going to be either 0 or 5 volts, because 5 volts is 1 for the Arduino. Now, next thing here, we've got a file. Too into detail in this, but basically this is just creating, while whatever is between this bracket is true, this will happen. But since I've just written true in here, this will continue on for forever, unless you type something like break into it. So that's for another day. So then what's happening here again is digital write 10 high, and then we're delaying 4 seconds. When you delay in Arduino, 1,000 is 1 second, so 4,000 would be 4 seconds. So then we're turning off 10 again then here, and then next we're delaying 1 second, and then we're making 9 go high, and delay 4 seconds, and then this continues on and on and on, and it never stops until you plug out the power. Okay, so I will control you and upload this. Okay, so after uploading the new program, you can see once I connect power, the motor starts spinning, and as we programmed it, after 4 seconds it stops and rotates in the other direction. This will be very useful in an upcoming project, but you will have to wait and see what it is. Okay, bye for now.